Welcome to part 2 on graphing cubics in factored form. We are going to do this last kind of challenging problem because we've got fractions, multiplicities, coefficients in front. So real quick, this squared means I would have 2 of my x plus 3's. So if I wanted to expand this cubic, I would have 1/3 x plus 3 times x plus 3 times 5x minus 5. So to predict the first term, I'm going to look at this 1/3, my x, and my 5x. So that'll help me predict the first term. These are just ones here. So I know 1/3 times 1 is 1/3 times 1 is 1/3. So I'm really just looking at this 1/3 and this 5x. So 1/3 and then a 5. If I multiply those two numbers together, I would get 5/3. So my leading coefficient is going to be 5/3. My first term would be x, and x, so x cubed. So 5/3 x cubed is positive, and so I know my graph is increasing. That's kind of all I really need to know. If my graph is positive, it's going to start down low and end up high. So I'm going to have an arrow down low and then an arrow up high. Now the hard part is finding the zeros and multiplicities. This 1/3 in front I can kind of ignore because there is no x attached to it, and I only care about solving for my x-intercepts. So one of your zeros is going to be a -3 from switching our sign. Now you do have a multiplicity, so you got a multiplicity of a 2. Whoops. So it is going to bounce off the x-axis because it is squared. The hard part is this factor right here. I could switch my sign to a -3 over here because there was a 1 in front of the x, but if there is a coefficient, I do have to do a little bit more work. So I need to actually set up an equation to find the x-intercept. To do that, you're going to set it equal to 0. So I would say 5x minus 5 equals 0 and solve. So add 5 to both sides. Cancel out. 0 plus 5 is 5. 5x equals 5. Divide by 5. X equals 1. So my other x-intercept is not going to be a positive 5 from switching the sign because of that coefficient. It's actually going to be a 1. Now, there is no exponent with this parenthesis, meaning the multiplicity is 1, so it's just going to cross through at a 1. So we got a bounce and we have a cross. Next, I'm going to look at my y-intercept. Again, y-intercept, we're going to plug in 0. So I would have 1/3, plug in 0 plus 3 squared, and then 5 times 0 minus 5. And let's do some mental math. So 0 plus 3 is 3. 3 squared is 9. So I've got a 1/3. My first parenthesis is a 9. 5 times 0 is 0. 0 minus 5 is -5. 1/3 times 9 is the same thing as saying 9 divided by 3. 9 divided by 3 is 3. 3 times -5 would be -15. So my y-intercept is at a 0, -15. So now I can head to graphing. So I'm going to add my x-intercepts. So boom, boom, boom at a -3. Got one x-intercept at a 1. And then 0 somewhere down here would be a -15. Bloop. All right. So my pencil is going to start at the bottom because my end behavior wants to go up and then, starts down, go up. So if I start here, the first number I go to is a -3. I know it says to bounce, so I'm going to go to -3 and I'm going to bounce right off of it. Then I'm going to head down to my y-intercept. Then my next x-intercept is a 1, so I got to quickly go back up there to 1, and I'm going to cross through it and be done. So again, see what number you approach first. Ask yourself if you should cross through it or if you should bounce back off of it. Always make sure you hit that y-intercept. It's kind of a helping way to show you where you're going. And then cross through at a 1. Okie dokie. Finish with graphing. Let's do one more problem. We can write the equation given a bunch of information. So number 4, write the equation of a cubic function with a double root at a 2, a single root or x-intercept at a 5, and the end behavior of the following. As x goes to negative infinity, y goes to positive infinity, x goes to infinity, y goes to negative infinity. So let's talk about what this means. This means on the left arrow, your y's are going up. So your left arrow, your y's are going up. On the right arrow, positive infinity, your y's are going down. So that essentially is going to tell you the end behavior, that your graph is opening down, which means it is negative. So when I write an equation, I'm going to start off with f of x or y equals, up to you. I'm going to have a negative in the front because of my end behavior. A double root added 2, so that would mean positive 2, switch your signs, would be negative 2 in your function. Double root, though, means it's going to be squared because there are 2 of them. And then a single root at a positive 5, so it'd be x minus 5. So that's how you can also write an equation from some information that they give you. There could be a number in front, but they did not tell us. So that's kind of all we do. Alrighty, that is how you graph cubics in factored form without a calculator. So you've got a Delta Math. Yes, it looks like a lot, but it's just one individual problem. And I handpicked these problems. So I'm going to show you how to do this because it's kind of tricky. So I would press pause, head over to Delta Math, and we're actually going to try this first problem together. So log in to 3.7 Delta Math. Once you're here, go ahead and unpause the video. So Delta Math says sketch the graph of the function below, including the correct signs, correct intercepts, and correct y-intercept. So this first problem, I need to figure out your roots. So x plus 2 would switch to x minus 2. There is no multiplicity, so it's going to cross through them. X minus 5 will switch to a positive 5, and we know it's going to bounce because of that squared. The next thing you need is the y-intercept. So I'm going to plug in 0. So I would have 0 plus 2, and then 0 minus 5 squared. 0 plus 2 is 2. 0 minus 5 is negative 5. Negative 5 squared is a positive 25, because anything squared will always be positive. And then 2 times 25 is 50. So what I'm going to do is take this information and put it on Delta Math. So it doesn't have to be perfect, which is the coolest thing ever. So one x-intercept, you're going to click at a negative 2. One x-intercept will be a positive 5. And then your y-intercept we found was 50. So somewhere in between 40 and 60, I'm going to put a dot, which is the coolest thing that's going to grade this, with it being estimation. Once you have your x-intercepts and y-intercepts plotted, hit done plotting. Now you are going to sketch a graph, and this is the part you're going to hate if you're on a Chromebook. So if you want to do it on a phone or an iPad, it's actually much better. I need to figure out my end behavior. So this graph is positive, meaning it's going to start going down and end going up. So on Delta Math, I need to start my pen somewhere down here. I'm going to cross at a negative 2 and bounce at a 5. So I'm going to start down here. We're going to cross at a negative 2. Oh. We're going to go to that y-intercept. We're going to head back down, and at this 5, I have to bounce off. Make sure you don't do this, because it will say you're wrong. I'll show you. It's going to yell at you because you crossed through the x-intercept. So hit redraw. So go up here, cross, go through the y-intercept, bounce, so boop, touch it, and then go back up. And then it finishes the graph for you. And watch this. This graph was not pretty. It's right. Okay. So Delta Math has this really cool grading thing. Okay. So yes, it's a little frustrating on the Chromebook. If you want to do it on a phone or an iPad, it might be better to help you trace. But that's what you guys are going to do today. Let me know if you have any questions. Thanks for watching, and you can get started.